Hello, this video is going to show how we can achieve functional safety using Wind River's VxWorks7. Now, this is Wind River Workbench, and inside here I've created a number of projects, and these are projects which are going to use VxWorks7. So I've got this particular project I'm interested in. Let's first of all check we can build it, and yes, that's built. And what this project does is basically it creates a number of threads which communicate together, and then after a certain time it deletes them and exits. So what I'd like to be able to do is first of all take a look at this code and see, well, is it compliant to MISRA 2012? I'd like to be able to measure some metrics on the code to find out, well, how complex is this code? And then I'd like to be able to execute the code, and as it executes I'd like to be able to find out, well, how much of this code have we exercised? And what we'll find is we won't get 100% coverage, and so then I'll use TBrun, the unit testing tool, in order to be able to complement that coverage. So we've done a build inside here. Well, now let's do a build, but within the LDRA build system import. So let's start the build, and we can see it's doing exactly the same as what we just did inside Workbench. But now LDRA has been able to parse the results of that build, and we can see we've found an executable. We've also found a list of the source files. We've got a list of the include paths, and also we've got a list of the preprocessor symbols. So we have everything we need now in order to be able to analyze this code. And I can do that just by opening it here with TBvision. Well, to save time, I've already analyzed the code, and let's take a look and see, well, is it compliant to MISRA? Well, in this particular case, we can see it's not compliant. We have a number of violations. Well, let's take a look at a violation here. So this one, pointer param, should be declared pointer to const. Okay, let's double click, and here we can see, well, this probably should have a const before here. Well, that's fairly easy to fix. Let's close that down, and let's take a look at another one. So here we have potentially infinite loop found. Well, that's more interesting, and we can see, well, this is actually the root of the thread, and of course it's an infinite loop here. So when we come to do the unit testing, it's going to be a bit more complex in order to be able to test that, because this function never ends. Right, let's close that down, and let's take a look now at maybe the quality of the code. Let's go and take a look at a system call graph. And a system call graph is showing us all the functions, and we can see how they're interconnected. And let's go and put this into a view where maybe we can view the metrics that give us an idea of clarity, or maybe the metrics that give us an idea of testability. But what I want to concentrate on here are the metrics that give us an idea of maintainability, and the cyclomatic complexity is probably the most useful. Now, we've got very small values here, but let's take a look at the task pong run. That's the infinite loop. And if we take a look at a graphical view of that on a flow graph, we can see the code is really not very complex, but we do have this while one. So what's this block here? Well, if I click on it, it shows me the corresponding block over there. What's this branch? Well, that's the branch where I exit the while one, so that's not feasible. All right, let's put that to one side, and let's go now and execute the code. So I just need to go and open this again because I closed it by mistake. That's okay. Right, so let's go now and execute this code. So I'm going to perform the dynamic analysis. So this is now going to instrument the source code. It's now done the build, and now it's going to execute on this simulator. So here we can see we've started the VxWorks simulator, and we're going to see that these two tasks are starting to print out different symbols, and after a certain time the tasks are going to get deleted and it will then exit. So there we can see that's now exited, and we've saved some files onto the host that we're analyzing. And so let's take a look and see the coverage. So once again, I'm going to go back to the system call graph. And this time I'm going to put this into a mode where we can view the coverage. So we can see we've got quite some good coverage, but let's take a look at maybe the task Pong run, and here we have 91% statement coverage. Well, let's take a look on the flow graph, and on the flow graph we can see very clearly exactly the parts we've executed. We've never executed this bit of code here, so task Pong has been waiting too long, so that's never been executed. And of course we haven't executed this bit of code to break out of this while one. So if I want to get 100% coverage on this code, then I can use the unit testing tool TBrun. So let's go and do that. So let's start TBrun, and inside TBrun what I'm going to do is I'm going to load a sequence that I've created previously. So inside here I've got a sequence that I've created for the task Pong. So let's open that, and there I've got 5 test cases. So the first one is going to create a semaphore, then I'm going to signal the semaphore, and then I've got the task Pong run. That's the more interesting one. Well, first of all, I've only taken task Pong, so I haven't included the other files, and so the functions were missing. These have been stubbed, and since they've been stubbed, well, I'm actually able to do things with those stubs. So let's take a look and see what I've set inside here. So I've said, well, when this function here, semTake, which has been stubbed, has been executed 10 times, I want to effectively exit that loop. And also I've set up return values. So the first time I call this, I want it to return 0, second time 0, and it looks like probably the 9th time I want it to return error. So set those up, and let's now go and execute this. So this is now going to generate a harness. It's just built it. It's now starting the simulator, and we're going to execute inside that simulator. So just need to wait for that to run, and okay, we've got the results back, and there we can see all our tests have passed. So that's good. So we can also now take a look at the coverage. And as we can see, we now have 100% statement coverage and 100% branch decision coverage for this task Pong. Okay, so hopefully that's given you an idea of how we can work with Wind River's VxWorks7. And if you'd like more information, then please don't hesitate to contact us at LDRA. Thank you.